Hello everyone, my name is Pradeep Bamgai and welcome to my class Fundamentals of Spline Modeling in Cinema 4D. I'm a digital artist, author and educator with over a decade of experience in CGI, and I'm the founder of Pedaxi Academy. This class teaches you spline modeling fundamentals using the spline tools and functions available in Cinema 4D. This class first introduces you to the spline primitives and then shows you the functioning of spline creation tools. Then this class jumps right into teaching you how to create 3D objects using splines, extrusion, sweeping, and braiding. By end of this class, you will understand the tools and techniques available to you for creating 3D models using splines. I hope you will join me in this journey to learn more about spline modeling with the fundamentals of spline modeling in Cinema 4D class, and I'll see you inside. In this clip, we will talk about what splines are. We will also talk about the spline primitives and spline tools. So let's get started. A spline is a sequence of vertices connected by lines, also referred to as segments. Splines are infinitely thin entities and are not visible during rendering. However, if you are using studio version of Cinema 4D, you can render splines using hair and sketch and tune features. The shape of these lines is defined by the interpolation method. The interpolation method defines whether the shape of the line is curved or straight. The curved splines have a soft leading edge without any sharp corner. You can create holes using splines when a spline lies completely inside the another spline and both splines are closed. And if two segments overlap each other, so in that case no 3D surface will be created, or you will see strange results. Okay, so Cinema 4D offers a number of predefined parametric splines known as spline primitives. These primitives are calculated using the mathematical formulae, and therefore they have no points or vertices to edit. However, you can convert a parametric spline primitive to an editable poly by first selecting it and then pressing C. So let me close this file. To access these primitives, you have to go to the generator group here. The spline group here, and then we have this pop-up in which in the first column we have the spline creation tools, then we have these spline primitives, and on the right we have options for Boolean operations. Okay, you can also access these primitives from create spline submenu. Here the entries are same what we have seen here. Alright, so you have two options to add any spline primitives to your scene. So if you click on this dotted line here, you can tear this menu from the standard palette, and the first option we have here is arc, the first primitive. So it creates arc type shapes. You can change radius, start angle, and the end angle. Next we have circle. You can change radius, you can set the plane on which this circle will be oriented. We have a checkbox here called ellipse. You can click on it and then change the radius y value to make it an ellipse. Alright, next we have as helix. Alright, inside we can change a number of sides. Okay, we have rectangle. We can set width and height, and we also have option for rounding the corners. We have star, text. You can type any text here and it will be displayed in the viewport. Then we have vectorizer. This primitive is used to convert used to create spline outlines from a 2D image. All right. Next we have four-side, seesaw. Okay. We have cogwheel, cycloid, flower, and profile. So you can, whenever you add a spline primitive, you can make it editable, because there are no points right now to edit this spline primitive. And if you enable the points mode from here, you will not get any points. So to make it editable, you have to press C on your keyboard or click on this button here. So now we have the points, and we can now manipulate these points using the transformation tools or the pen tool or the other tools listed here. We'll talk about these tools in a later video. Okay, so we will be using these splines in the tutorials that we will create later in this course. Okay, so in the next video we'll talk about the sketch tool. The sketch tool is used to directly draw in the viewport and to edit the existing splines. For example, you can use it to redirect, smooth, and correct splines. This tool obeys snap settings, and these snap settings are particularly useful when you want to draw a curve on the surface of an object, and this tool works very well with tablets. Okay, so I don't have tablet attached to this computer, so I'll be using mouse while demonstrating the functioning of this tool. So to enable this tool, go to the spline group here and choose sketch, and then you can click and draw like this. Okay, like a pencil or a pen. So when you invoke this tool, we get the options for this here in Attribute Manager, and the first thing here we have is the radius, and right now it's 0, so you can change it from here, or you can interactively change in the viewport by middle mouse dragging. Okay, so using this tool, a spline can be grabbed at any location and edited from that location. For example, when you hover your cursor over any line segments, you will see the outer you will see these two dots there, orange dots, and you also have the radius helper there in form of a circle. So just click and drag, so you can edit line from anywhere. You can just click and drag. Alright, separate splines and spline segments of a spline can be connected at their ends. Okay, if a spline segment's start and end points are connected, the spline will be closed. So let's connect the start point and the end point here. Before that, let's enable the snapping, so it will be a little easier for us. So enable snap from the snap menu, and then make sure that vertex snap is on. And now let's drag from the start point to the end point here. So now it's a closed spline. Okay, you can also connect between two lines of a spline. So let me go ahead and choose pen tool here, and right click on the edge and choose kill edge. So now we have a gap there. So now if we use the sketch tool, we can connect the segments of a spline. Okay, separate splines and spline segments of a spline can be connected anywhere along the spline. For example, if you want to connect this part to this part, just go ahead and click and drag. Okay, like if you want to connect this part to this line, you can do so. Alright, If you press shift while this the sketch tool is active, Cinema 4D switch back to the spline smooth tool temporarily. So just press shift and now you can smooth your splines using the shift key. Press and hold the shift key. Okay, so this is how we use the sketch tool. Next we'll talk about spline smooth tool. The spline smooth tool works as a shaping brush. It not only allows you to smooth the splines but also offers a number of other features that can be combined seamlessly. You can adjust the strength and radius of this tool by dragging the mouse pointer vertically or horizontally. So let's go ahead and activate this tool, spline smooth. Now we have here radius and strength, and then we have the functions of this tool. So if you click middle mouse button, click and drag horizontally, you will change radius interactively, and if you middle mouse drag vertically, you will be changing the strength of this tool. Okay, let me go ahead and reduce the radius. This tool can create lots of points on the spline if we are using the random function. So here we have the random function. If you click and drag using this tool, you can see that it will be creating a lot of points here. So to fix this, you can go back to the smooth mode and smooth the spline like so. Okay, so the default function of this tool is smooth, as you can see here. You can also flatten the spline. You can also random, we have just seen. You can also pull the spline segments. Okay, you can also make a spiral like this, and you can also inflate the spline. Okay, so you have a lot of functions here with this with the spline smooth tool. Next we'll talk about the spline arc tool. You can use the spline arc tool to create variety of arc shapes and soft connections between segments. This tool creates 3-point circle and obeys snap settings. To create an arc, 3 points are required: start point, middle point, and the end point. So let's go ahead and activate spline arc tool. Click and don't release the mouse button and drag. So now we have first point, or the start point, and the end point. Now release the mouse button, click and drag the segments up or down to create the shape. So once the drag operation is complete and you release the mouse button, you will get this helper here. This click and drag on this edge to define the start angle, on this edge to define the end angle, and you can drag this middle point to change the shape of the arc. This point can be dragged only perpendicular to the arc shape we have here. Okay, another way to create arcs is, let me escape. You can connect two lines with an arc. So let me go ahead and activate the pen tool and create one spline and the other segment. Now activate the spline arc tool, click and click to create a connection between these two segments using an arc shape. Okay, you can also create shapes like this. All right, I'll show you one method in which you can change the shape of the corners of spline primitives. So I have a rectangle here. Let me move it over to this side, and I'll give it some rounding. Then I'll convert it to editable object by pressing C on my keyboard, and then choose the points mode from here. Now select the spline arc tool, click and drag on this segment to create shapes like these. Okay, so this is how we use spline arc tool. The pen tool is used to create or edit splines. It replaces the previous Bezier, B-spline, Linear and Akima spline tools and provide a wide variety of new functions. To create a spline, invoke the tool and then click on the view to create a point. If you drag the mouse pointer, a tangent handle is created to produce a curved section. A ghost preview of the next section is shown before you create the next point. It helps in visualizing the next segment that will be created if you click to create next point. If you just click and drag, just click and click, you will be creating sharp corners. So once you are satisfied with your spline, you can press escape to finish the spline. Okay. The points created using this tool can be selected and moved without need of selecting them. Okay, you don't have to select them first. When you click on a point or segment, the tangent handles are displayed and that can be edited. If you want to extend a spline at the beginning or at the end, select the respective point and then start drawing. Okay. If a point is selected on the spline, which is not the end point, then you can press Ctrl to continue at the spline's end. Press Ctrl and then you can continue drawing the spline. Okay. Here notice that we have a gradient going on here from white to blue. So white indicates the start of the spline and the blue represents the end of the spline, and this gradient fades from white to blue. If you position mouse pointer on a segment, it will be highlighted. Okay, and if you right mouse button click here, you will get options. Okay, that will work on the highlighted segment. So for example, if we select kill edge, it will delete the segment, and you can also create that segment using this tool. Okay, next option is add point. It will add a point there. Next is hard edge, and to switch back to soft edge, select soft edge from this menu. And if you highlight a point and right click, then we have other set of options like delete point, so it will delete the point. Disconnect point, it's like splitting, so you can notice that now the blue ends here and then the white starts, because now we have splitted the point and we have two separate splines. We have a single splines, but there's a gap in the splines. Okay, next option we have here is we need to invoke the pen tool, is soft tangents. Okay, so we can, if we have the corners like this, we can right click and choose soft tangents. So it will go ahead and give us handles that we can manipulate to change the shape. Okay, you can move points and segments using this tool. Okay, if you press shift and drag one of the tangent handles, it will break the tangents, and now you can individually control the handles of the tangent to define the shape. Okay, you can always right click here and switch back to soft tangents, and it will unify these two handles. Okay, Double clicking on a point toggles between the soft tangent and null tangent. Okay, it toggles between the soft and null tangent. If you hover mouse over the spline with the control held down, okay, like so, a preview appears that shows where a matching tangent will be inserted. So we have inserted a point there, and control clicking on a point will delete it, and a ghost preview will also be displayed that will show you where the new connection will appear. So if I control click on this point here, the new connection will go from here to here, as we can see in the ghost preview. Okay, if you connect the start and end points, you will be creating a closed spline. Click and then drag. So we have now closed the spline. Okay. If we connect two spline objects using this tool, let me create two splines here, close the file, and I'll create a spline here, press escape, and then create another spline and press escape. So now we have two splines here, spline 1 and a spline. Let's connect them using the pen tool. And notice here that we have now only one spline. Okay, so whenever you connect two splines, two or more splines, they will be converted into single spline. So this is how we use pen tool on spline. In this lesson, we're going to talk about the extrude object, which extrudes a spline to create an object with depth. So let's explore it. For that, I'm going to create a rectangle spline and change its plane to XG. Now I'm going to create a copy of this rectangle by control dragging here in Object Manager, and then I'm going to change its width and height to 300. I'm going to enable the rounding option here and set rounding to say 60. Now I'll connect these two splines, so go ahead and select these two, and then I'll go to mesh conversion, connect objects plus delete. So now we have single object here, single spline. Now I'll apply the extrude generator to it, and here the first option we have under the object tab is the moment, and this is the extrusion distance along the X, Y and Z axis based on the local axis system of the extrude object. So you can see here G axis is pointing towards right, so we don't need that. I'll go ahead and set it to 0, and I'll set the moment Y to 50 units. I'll also enable the shading line mode. Alright, so next option we have here is subdivision, and it defines the number of subdivisions along the extrusion axis. You can see here along the extrusion axis, which is Y in our case, and you can see that the subdivisions are changing along the Y axis. Next option we have ISO subdivision, and ISO subdivision will only be visible in the viewport if you change display to isobomb, and then you can change the number of subdivisions. Okay, let's switch back to lines mode, wireframes. Next option is flip normals, that is used to reverse the direction of the normals of the extrude objects. Generally, Cinema 4D will point the normals in the correct direction. However, in some cases where open contours are there in the model, it is not possible for Cinema 4D to know which way they should point. So in that case, you can use the flip normals options. Next is hierarchical. If this option is enabled, you can group, say, several splines within a null object and then extrude them. I'll give you an example for this. Let's create a text spline. If I press C to make it editable, you will notice that we have a single spline here. But if you have enabled, let me undo the last operation, but if you have enabled separate letters option here and then you press C to make it editable, now we have a null object and each letter has its own spline here. Okay, so now let's put it under a subdivision, under extrude generator, and nothing happens here because it's a null and then we have these splines. In order to extrude these splines, we have to select hierarchical option for the extrude object, and then we can set the extrusion amount. Okay, so this is how hierarchical work. Let me go ahead and delete this. So we have our original object here. Next we have caps tab here, so we can set caps for start and end. We can say none, we don't want any cap, so we'll have a surface like this. We have fillet for start and end, and then we can set the radius and number of segments or steps. Okay, this is fillet. Likewise, for the end, we can set number of steps and the radius. Or we can cap this area using fillet cap. Fillet cap. Okay. Then we have fillet type. We have convex. Let me zoom in on this object. We have convex, concave, we have half circle, one step, two steps, and engraved. So whatever it is you are looking for, you can use that. Yeah, let me switch back to convex. Okay, the option here is these two options, hull inwards and hole inwards. They control rounding inwards and rounding outwards. So if you click on hole inward, you can see here the effect. This is hull inward, sorry, hull inward. So the hull is now inside, and the other option is hole inwards. So these two options affect the rounding. Okay, so next options we have available here are constrain and create single object. Constrain is the option for, this setting determines whether the object's dimensions are preserved or whether the object should be inflated by the rounding. So if it is on, the object's dimensions are preserved, and if it is off, then the object will be inflated by the rounding. Okay, create single object is if you, for example, convert this extrude object into editable poly by pressing C, you will notice that now we have two polygon object, rounding 1, rounding 2, then we have cap 1, cap 2. So we have separate objects here. But if you want a single object out of this, so let me undo last steps, then you can check this create single object, and now when you press C, you will have only one polygonal object. Alright, so this is how this option works. And the rounding UVW keep shape, if this option is enabled, the rounding and the cap surface will create a common UV island. So let me go ahead and add a material to my material manager. Now I will go to texture and then choose surfaces and tiles. Okay. And now I'll apply this to my extrude object. So here we have the caps and here we have the rounding. Right now they are not sharing the same common UV space, but if I go ahead and now select rounding UVW keep shape, you'll say that they are now sharing the same UVW space. This is how this option works. And the last setting here we have type, that is used to define if the caps should be consist of triangles, quads or n-gons. Okay, so this is the quick overview of extrude object in Cinema. In this lesson we're going to take a look at the subdivision surface tool. This tool is one of the most powerful modeling tools offered by Cinema 4D to a digital artist. You can create almost any shape using the point weighting and edge weighting. This tool uses an algorithm to subdivide and round the objects. You can use any kind of object with this tool. However, most of the times you will work with polygons. So I'll go ahead and create a simple cube, and then I'll add a subdivision surface modifier to it. Okay, now I'll turn on the lines mode here and convert my cube into editable poly by pressing C. Okay, now I'll switch to the point mode and I can select it and select the original the points on the modified geometry and then change the shape. I can also turn on SDS cage from the filter menu here. So now I have the cage. So I just can't select the points on the cage. I have to select the points on the modified geometry, and then I can make changes like this. Okay, if you want to in order to select the points here on the cage, you have to turn on the isoline editing option, and it can be found here in the options menu. Alt A is the shortcut. So now you can select the points and manipulate these points. The shortcut for enabling isoline editing is Alt A. Okay, so now we can select the points on the cage and we can modify the geometry. Okay, now let's go ahead and right click on the viewport and choose loop path cut tool. You can also press M and L or K and L. So let's select it and make sure the mode is set to loop, and now I'll create some subdivisions here. So you can see that now, because we have more subdivisions here, we are getting this rounded shape. So I can go ahead and create more segments. So now we have a smooth cube. Okay, well, let's undo this and undo these steps, and now we'll use interactive weighting. So in order to use interactive weighting, we have to select the elements like points, edges or polygons. You need to select the points, edges or polygons that you want to weight, and then hold down the period key, that's the full stop key on your keyboard, and then drag left or to the right to set the weighting for the selected elements. So now let's first select this point here and shift select another point. Now hold down the period key and then drag to see interactive weighting in action. Okay, so to weight the selected points, hold down the period key and drag. To weight the selected points and all edges connected to them, hold down period key and then shift drag like so. Okay, to weight selected points and the edges between them, hold down the period key and then control drag. To set the minimum and maximum weighting that you can apply by dragging, you need to select the live selection tool, and then here under subdivision surface you can set the interactive minimum value and interactive maximum value as well as the strength. Okay, so the interactive weighting is available for edges as well, edges and polygons. So let's select this edge, Alt and the period key and Shift drag, or the period key and Control drag. Okay, let me select two edges here. Now press and hold period, press Control and then drag. Okay, let's try on polygons. Select a polygon, hold down period key, Shift key and drag, or hold down period key and Control drag. So for control dragging this face, we get this rounded shape here. Okay, now if you notice here in the object manager, we have a tag, and that tag is sort of a heat map or the weight map for the object. So blue is the minimum weighting and red is the maximum weighting, and then it fades between the blue and pink and red. For example, if I select this edge here and I press and hold the control period key and then the Shift key, and I drag the cursor, you will notice that as the geometry is moving towards that edge, the weighting is turning from blue to red. Okay, and here you can also change in the attribute manager, you can change the subdivisions. But before that, let's have a look at the subdivision editor and subdivision renderer settings here. The subdivision editor is affecting the subdivisions for the viewing purpose only in the view I mean. So if you render this, we have the subdivision level 2 in the view, but when Cinema 4D renders it, it uses the subdivision renderer setting of 3 here. So if you want to see what you see in the view, if you want to see that view in the, if you want to see that in render as well, so you need to set these two values to same number. So what you will see here in the view, you will get in the renderer. Alright, but for some reason, if you want to change it using this tag, you can do so. Just enable change subdivision checkbox and then change the values here. Okay, so that's a quick introduction to the subdivision surfaces in Cinema 4D. In this clip, we're going to talk about the lathe object. The lathe object rotates a spline about the y-axis to generate a surface of revolution. For example, you can create a wine glass from a simple profile. Usually the profile should lie in the XY plane because the profile will be rotated about the y-axis. So I'll go ahead and I'll activate my front viewport, then I'll invoke my pen tool and I'll quickly create a profile. Let me fine-tune it a little bit. This is it is for demonstration purpose, so it doesn't need to be perfect. Alright, now the next step I want to do is I want to make these 2 points lie in a line in 3D space, because when we'll connect lathe generator to it, there will be hole in the geometry. So we need to make these in one line. So select this point here and set x, y and g values to 0. So now it sits at the origin, and for the end point set x coordinate to 0. Okay, now connect lathe generator to it, and there we have the surface. I'll also enable the lines mode. Now here in the object tab, the first attribute we have is angle. Here you define the angle through which the spline is rotated. So, okay, 360 degree is one complete turn. So if you reduce the value, you'll get a surface like this. So 360 degree is one complete turn. Okay. Next is subdivision. It defines the number of subdivisions along the rotation. You can see here. Next is isopalm subdivision. It defines the number of isopalm used to display the lathe object when the isopalm mode is on. Okay. Next is movement, which defines the longitudinal distance from the beginning of the lathe to the end. Okay, by default it's set to 0, but if you change this value, you can create helix-like structures. Okay, I'm going to switch it back to 0. The scaling attribute controls the final scale of the spline. The spline is scaled with respect to the origin of the local axis system of the generator. So you can go ahead and scale your spline. To create such shapes. Okay. Flip normal is used to flip the it is used to reverse the direction of the normals of the lathe object. Usually Cinema 4D points the normals in the correct direction. However, in cases where open contours are in the geometry, it is not possible to know which way they should point. In that case, you can use this option to create a lathe object. You can use this option to fix that issue. Alright. So this is the quick introduction to the lathe object in Cinema 4D. In this lesson, we're going to talk about the loft object. It stretches a skin over two or more spline. So I'll go ahead and add a rectangle spline and change its plane to XG. Now I'm going to add a circle spline, change its plane to XG and move it along the y-axis. Next, I'm going to go and create a flower spline, plane XG, and place it like this. Okay. Now we need to add a loft object, loft generator, and connect splines with it. So the order of the spline is very important. At the bottom we have rectangle, then we have circle, then we have flower. So the shape is according to that. Let's make more distance between the splines. So I'll select it and move like this. Okay. I'll also enable the lines mode. So the first option we have for the loft object in the object tab is mesh subdivision U. It controls the number of subdivisions in the U direction, that is along the circumference of the cross section. Okay, and mesh subdivision V is the number of subdivision created in the V direction, that is along the length of the loft. Okay, next we have isopalm subdivisions, and if you have enabled the isopalm display mode, then you can set isopalm subdivisions from here. I'll switch back to wireframe. Next is organic form. If this option is disabled, what happens is that the loft object lines passes directly through the spline points, and the distances between the lines adapt to the spline points, resulting in a very tight form. But when you enable the organic form option, the loft object lines no longer pass through the spline points exactly, but maintain equal parametric distance to each other, creating a looser, more organic looking form like we can see here. So this is disabled and this is enabled. Next is subdivision per segment, which is on by default. You can use this option to choose whether the mesh resolution is divided evenly over the entire length of the object or evenly per segment. Okay, enabling this option gives you more control over the object's appearance when splines are closer to each other. Okay, now the loop option. Before we move to loop, I want to talk about the adapt UV, which is similar to subdivision per segment but refers to the texture instead. Okay, the texture is projected either per segment if it is enabled, or evenly over the entire object if it is disabled. Let's go ahead and create a material and apply it to the loft object, and then apply a texture to the color channel. So I'll select surfaces tiles. Okay, now you can see the difference when the adapt UV is on. Okay, so the texture is right now it's on, so texture is projected in per segment. Okay, but when it is off, it is evenly projected over the entire length of the loft object. Okay, let's delete this tag. The loop option here, when enabled, the first spline is connected to the last spline in the V direction. So if we enable the loop, you can see we get this kind of shape. And if we put this loft object inside a subdivision surface object, we can create some interesting looking shapes. Let me delete that. So this is how loop works. Next is linear interpolation. You can enable this option if you want linear interpolation between the splines. Okay, it's a very tight interpolation, or otherwise if it is off, this object will use smooth or soft interpolation. Okay, so this is the quick introduction to the loft generator in Cinema 4D. In this lesson, we're going to talk about sweep object. The sweep object requires 2 or 3 splines. The first spline, called a contour spline, defines the cross section, and then that cross section is swept along the second path spline to create an object. Okay, the third optional spline, called rail spline, can be used to modify the scale of the contour spline over the object's length. Okay, so I'm going to go ahead and create a helix spline, change plane to XG, then I'm gonna change start radius to 50 and end radius to 50, and then I'm gonna reduce the start angle to create a shape like this. Okay, so this is our path spline. Now I'll add a cross section using the circle spline, and for this I'll reduce radius to 10. Okay, now I'll go ahead and add a sweep object and connect circle and helix with the sweep object. So now we have the surface. The circle is swept along the helix to generate this shape. Okay, let's enable isopalm mode. Okay, let's have a look at the commonly used parameters here. The end scale, it defines the size of the contour at the end of this spline. end of the path. What I meant, the contour is 100% at the start of the path here, and then the size is interpolated between 100% and the value you specify here for the end scale parameter. Then we have value for we have attribute for end rotation. Okay, it defines the rotation about the g-axis that the contour has passed through by the time it reaches the end of the path. Then we have a parallel movement. When you enable this option, no rotation will occur. Okay, the contour is swept in a parallel manner. So if this is the desired result, then you can select it, otherwise go ahead and clear it. Okay, next we have constant cross section. This option is enabled by default, and to demonstrate this I'll create a star spline, and on the XG plane let's create a copy of the circle spline and add a sweep object and connect this star and circle. And first we need to place circle inside the sweep, then star. So we have this shape here now. Now select sweep 1, and the default option, by default the constant cross section option is on. Okay, so if we turn it off, you can see the difference in the shape. Okay, the default setting is on. The other option we can use is banking, and banking is when this banking option is enabled, the contour spline will lean into the curves of the path spline. So this is a quick overview of the sweep object in Cinema 4D. In this lesson we're going to talk about the tools, functions and commands available under Mesh Spline submenu. So I'll tear off this menu, and the first option here we have is the hard interpolation. This command changes all selected points to hard interpolation. If no points are selected, all points on the spline are changed to hard interpolation. Okay, so when you execute this command, Cinema 4D essentially sets the length of the tangents to 0. So I have no points selected here. So if I go ahead and click on hard interpolation, all points will change to all will adopt the hard interpolation. The next command we have here, this is soft interpolation. It changes all selected points to soft interpolation, like this. Okay, the equal tangent length command, what it does that the shorter handles is set to the length to that of the second associated tangent. Okay, so if I go ahead and change the size of tangents of these two guys, okay, now I'll select these 2 points and execute this command, equal tangent length. So you will notice that the length, the shorter tangent handle is set to the length to that of the second associated tangent. So let's go ahead and execute this command, equal tangent length. Here we go. Okay, the equal tangent direction command is used to restore the smoothness of the broken tangents, and you can break tangents by shift dragging the handles. Okay, let's break these two, and then make sure that these 2 points are selected, and then execute the command equal tangent direction. Okay, the join segment command, you can use this command to connect several unconnected segments. Okay, so to connect the segments you need to select one or more point on each segment and then use the join segment command. So let's close this and create a new spline here and another spline. Now we have 2 segments. So what we need to do is we need to select these 2 points. Okay, and then execute the command join segments. Okay, the break segment command is used to create new spline segment. So to break spline, select one of the points and then execute this command. So let's select this and break break segments. Okay, so we had less segments here, so let me go ahead and create a fresh spline here with more segments. Okay, now select this point here and choose break segment. So we have now broken the segments here. Okay, so this is how this command is used, break segments. Next is explode segments. You can use this command to split a spline into separate object. For this command to work, you don't need to have a selection or the points mode active. Okay, the new splines becomes child of the original spline. So to demonstrate this, I'll create a text spline. Move it over here. Now press C to convert it to editable spline, and then select explode segments from this menu. And now we have the original spline text, and then the broken splines are children of the parent spline. You can use the first point, set first point command to make the selected point first point of a spline. Note that the start of the spline is displayed in white color, whereas the end is displayed in the blue color. Okay, so to make a point, the first point, what you have to do is you have to first select it and then execute the command set first point. So now the white color is starting from here and blue is ending here. So you can select any point and make it the first point. Okay, next is the reverse sequence. Use this command to reverse the point order of a segment. Okay, this command can be applied to several segments of a spline by shift selecting various segments. So we can reverse the sequence. Okay, and we can also move up the sequence or move down the sequence. So when you use the move up sequence command, the sequence number of each point is decremented. Okay, move up sequence. And when you use move down sequence command, the sequence number of each point is incremented, and the last point of the original sequence becomes the first point in the new sequence. Okay, the online smooth command is similar to the the spline smooth, not online. The spline smooth option here is similar to the functioning of this option is similar to that of the spline smooth tool we discussed in the previous videos. So go ahead and check that. Now the chamfer command, this tool is an interactive tool that you can use to convert a selected point or points with soft interpolation between them. Okay, convert a selected point to 2 points with soft interpolation between them. If no points are selected, the entire points on the spline will be chamfered. So I'll go ahead and create a rectangle spline. Move it over here and then press C to convert it, and then select points. If I do not select any points, all 4 points will be chamfered. So let's go ahead and click on chamfer. So here we have setting for radius. You can go ahead and click and drag in the viewport to set the radius interactively, or you can specify here in the attribute manager. If you want flat corners, you can check this flat switch here. Okay, create outline tool is also an interactive tool, and it is used to create outline around the original spline. Okay, like this. Alright, the line up command here can be used to align sequentially selected points to a straight line. So if we have points like this, okay, we can select now these top points and execute the command line up. So these all points will line up in a straight line. Okay, press Ctrl G to undo this last operation. And the round command, you can use this command to round and subdivide the sequentially selected points of a spline. Okay, these are sequentially selected points, and when you execute this command round, it will you can set number of points here and then click apply. So it will subdivide the sequentially selected points of a spline. You can use the project command to project a spline onto an object. So let me go ahead and create setup for this. I'll create a sphere and a helix spline. I'll change plane to XG and I'll align it like so. Let's reduce the radius to 100. Start and end radius. Now we need to convert this spline to editable spline. So select helix, press C, and now click on project. Change mode to spherical. You have different modes here. In this case, I'm choosing spherical, and then hit apply. So now that spline is projected onto the sphere. At the bottom of the menu, we have commands for Boolean operations. These commands you can also find here in the spline group. Okay, so here I have got two circles overlapping each other, and now the first command we have here is spline subtract. Okay, it depends which object you first select. So if I select circle 1 first and then circle, so this is the operation. And if I first select circle and then the circle 1, then I get this output. Okay, so the order of selection is important here. So we have subtract. Likewise, we have union operation. We have spline AND, that is the intersection of the two overlapping splines. The spline OR is the opposite of the spline AND function. And when you execute this, you won't notice anything changed here. But if you select points mode and just move them slightly, you will notice that what output this command has produced. So this is the output of a spline OR. Likewise, let me undo it a couple of times. The last command here is a spline intersect. So select the splines and apply this command. Again, we have to move these points in order to see the actual effect of this command. Likewise here at the bottom. Okay, so this is the output of spline intersect command. So this was a quick overview of the tools available in the mesh menu. In this clip, we'll create a model of a pair using a spline and a lathe generator. So first we'll import the image of the pair to viewport background, and then we will use the pen tool to draw the profile of the pair. Then we'll use a lathe generator to create the surface of the pair, and finally we'll use a cylinder primitive, add a bend deformer to create the stem. So I'll go ahead and create a new scene and then activate the front viewport. From Windows Explorer, I'll drag pair.jpg to my viewport background, and then I'll go to the options and configure option here. You can also press Shift V, and in the back tab in the attribute manager, I'll change transparency to 65% and offset Y to 435. So now we have the pair at the origin. Now we need to activate the pen tool from standard palette, and then we need to create shape. We need to create the profile curve for this pair shape. So start from here, click and drag, and then here click and drag. Don't worry about exact placement of the points because we can always come back and fix that. Okay, press escape to complete the curve creation process, and then you can come back to the points and adjust the shape if you want to. Okay, next select this point and make sure that X and Y, G is already 0, X and Y is 0 here in coordinate manager. So now the point is at exact origin, and for this top point here, let me change its position. For the top point, we need to set position X to 0. So now these 2 points, this point and this point, is in line in 3D space. So it will ensure that there will be no hole in the geometry when we will apply the lathe generator in the next step. Okay, so next what we need to do is we need to select spline here in the object manager, and then we need to go to generator group, hold down Alt, and then click on lathe. So by pressing Alt, what will happen that the spline object will be child of the lathe object here. And if you look at the model here in perspective viewport, we have now the shape of the pair. So we can enable display mode to crowd shading lines, or you can press NB. Okay, now select lathe here, and in the select the spline object here in the object manager, and then set intermediate points to natural. So we will have the equal distribution of subdivisions here, and then set number to 10. Okay, so the option here in the intermediate drop down define how the spline is further subdivided with the intermediate points, and this settings only affects when spline is used with the generator objects. Okay, when you select the natural method for interpolation, the number field here corresponds to the number of intermediate points between the vertices. Okay, the points on the curvature are positioned closer together where the spline has more curvature. Okay, now we'll add a bend deformer to this shape here to bend it a little bit. So add a bend deformer and make sure it's below the spline in the hierarchy, lathe, and then 2 children here, spline and bend, and order should be like this. Now select bend, click fit to parent. Okay, and then set size Y to 430, like so, and then we'll give strength, say -16 here. So now we have a little bit of bend going on here. Next we'll create a stem for this pair, and for that we'll use the cylinder primitive. So for that, go ahead and add a cylinder primitive, and the radius change it to 6, height to 79, height segment to 24, and rotation segments to 24, and then align it at the top of the pair also in the right viewport and in the top. It should be at the center. Okay, now we'll apply the bend deformer to it. So hold down shift and click on bend. Next click on fit to parent and set its strength to say -120. Okay. Now if you want to increase the number of subdivisions along the rotation of the curve, you need to select the lathe object. Okay, and then change value in the subdivision field here. Alright, I'll set it back to 24. And you can also use the isopalm subdivision to define the number of isopalms used to display the lathe object. So for this you have to set display to isopalm, and then you can use this setting here, isopalm subdivisions, to change the isopalm subdivisions of the model. Okay, so I'll switch back to wireframe, display wireframe. So this is our pair model, and this concludes the tutorial. In this clip we will model a glass bottle and liquid using lathe generator. So we'll first use a background image to draw a profile of the bottle using the pen tool, and then we'll create surface using the lathe generator. Next we'll use the split function to create the liquid. So let's get started. I'll go ahead and create a new file and activate the front viewport, and then I'll drag bare.jpg to my front viewport. Go to options and configure, or press shift V. Here in attribute manager, in the back tab, set size X and size Y to 400. Transparency changes to 65, and change offset Y to 188. Okay, now the bottle is at the origin. So activate the pen tool and start drawing the profile of this bottle. So I'll click here once, because this is the point where I want to create the level for the liquid. So make sure that you create a point there, or you can also create later on using the cut tool. You can cut the spline to create the level. So you can do it now or you can do it later, whatever is your preference, and then continue drawing the shape of the bottle. Here, press escape, and now you can come back and adjust the shape if required. So as we did in the previous tutorial, the bottom point should be at the origin, so we need to select it and then change X and Y positions to 0. Okay, let's rename this as bottle, the spine. Okay, now we need to create the outline for this curve. So right click and then choose create outline, and click and drag to create outline here. But by default Cinema 4D creates a closed shape, but we don't need that. So we'll select bottle here, and then in the object tab we'll clear this close spline checkbox, and again we'll make sure that the top point is at 0 along the X coordinates. Y is fine. So now we have this spline with the outline, Now we'll get rid of these points to create flat shape inside the model. So let's select these and this one also. Okay, so we don't need this kind of curvature inside the model, so I have deleted these points. And now we can right click here and choose soft interpolation, and then using pen tool we can correct the shape. Okay, so next thing we need is lathe generator. So make sure it is selected, go to generators palette here, press and hold Alt and then click lathe. So now we have the bottle. Now we can select the bottle in object manager and change intermediate points to uniform, and also enable the Garaud shading lines mode so that you can see the subdivisions on the bottle. So now the bottle is ready. Now we need to create the liquid. So for that, first turn off the lathe object, and for liquid select the inner points using the shift key, or you can click and drag if you have screen real estate available. So now we have selected all inner points up to the point where we want the level of the liquid. So now we have selected all these points. Now what we need to do is right click and choose split, or you can press U and P to split the spline. So we have the second spline here with the name bottle.1. Click and drag it outside the lathe group, okay, and rename it as liquid. Okay, so now we have this liquid here, the first point. I'm sorry, this one is the first point. Okay, now we need to extend this point to this middle green line. So go ahead and select pen tool, and it's automatically connected there. Click once, and we can change this interpolation to soft so that it's not that sharp there. Soft interpolation, and now we need to adjust the shape. For this liquid, okay. The next step is to add lathe generator to our liquid spline. So go ahead and press Alt and click lathe. So now we have the liquid here and bottle here. Okay, so let's select the lathe 1 object and drag it in the viewport so that you can see both the liquid and bottle. There is something wrong here at the top of the liquid, so let's undo that. Turn off the lathe objects, and select liquid. This point should be at 0. The exposition of this point should be 0. So press 0 on a keyboard, and now it should look fine. Okay. So if you create a material and turn on the transparency for this and apply it to the bottle, you can see the object inside, which is our liquid. So let's create another material and give it some color. And apply it to the liquid object. So now we have the glass and the liquid. So this concludes this tutorial. In this clip, we will model a martini glass using the lathe generator. First, we will create glass and liquid as done in previous clip. Then we will create the umbrella object using the cone primitive. Finally, we will use the box and cylinder primitives and the array function to create sticks. So let's start. I'll go ahead and create a new file and activate my front viewport and then drag martini glass image to my viewport. Now press Shift V to open the viewport settings. Head over to back tab here and then set size X to 300. Clear the keep aspect ratio checkbox and then set size Y to 456.472. And now change offset X to 2, offset Y to 194 and transparency to 65%. Alright, so now we have this image here. Now activate the pen tool and start creating the shape. Now draw the inner profile. Press escape and now we'll fine tune our shape. This point should be at 0 XY position. So we don't have tangent handles for this point because we just clicked, we didn't drag the cursor. So what we need to do is we need to change it to soft interpolation, and now we can adjust the shape. Similarly, we need to change these to soft tangents. And this point also should be at 0x position. Okay, now connect the spline with the lathe object. Press NB to enable go route shading lines mode. Now change intermediate points to uniform, and to smooth out the curvature, just increase the subdivisions. Okay, now we'll hide our spline, our lathe object, and we'll switch back to the front viewport. And now it's time to create the liquid. So we don't have points here for the defining the height of liquid inside the glass. So what we'll do, we'll create, make sure spline is selected, and then right click and choose line cut, and then make a cut like this. So now we have 2 points there. Now we need to select these inner points And if you recall from the previous tutorial, we need to split the spline to a new spline. So choose split from right click menu or press UP. So now we have a separate spline here. Let's drag it out of this lathe group, and now we need to connect, activate the pen tool, and we need to connect this point to this green line here. Okay, and then adjust the level. Okay, and connect this new spline with the lathe object. So this is our liquid. We can increase the number of subdivisions, and this is our glass. Okay, now next thing we need to create is the umbrella. For that we'll use a cone object. Just move it over, and here in the object tab of attribute manager, change top radius to 10, keep bottom radius at 100, and change height to 57. Okay, now we need to create holes here. So switch over to caps tab here and clear the caps checkbox. Okay, next we need to create a cube object, and in the object tab here in the attribute manager, set size X to 120, size Y to 8, and size G to 8, and align it with the umbrella. Okay, now we'll create copies of this object, and then we will rotate it. So for that we need to first group it inside a null object. So make sure cube is selected here in the object manager, then press Alt G to create a null object, and then in the top viewport move the axis. For that first we have to enable the axis, so press L or click this button here and move it at the center of the cone, and then press L again or click on this icon to disable axis. So now we have axis there. Next thing we need to do is we need to create an array object. So for that, make sure that null is selected here, press and hold Alt and then click on array button here. So by default Cinema 4D creates 7 copies, but we need 8, so change this to 8 and radius to 0. Okay, now select the cube object here inside null and activate the rotate tool, and then rotate this cube around G axis. Also move it down. Okay. And use the move and rotate tool to align these sticks to the umbrella. Okay. Next thing we need is a cylinder. So go ahead and create a cylinder, and let's align it with the umbrella. So in the object tab we need to reduce radius and height as well. Let's make it 10 centimeter. Alright, now to create the umbrella stick we need a cube object, and we'll also align it with the umbrella. Let's say 10 size X and 10 size Y, or 10 size Z and 100 size. Let me undo the view changes and let's move it like this. Okay, let's make it 15 centimeters in size X and 15 centimeters in size Y, and then we can let's switch back to 10. The height to 180 centimeters. Move it down like so. Now select cube, cylinder, array and cone in the object manager and press Alt G to group them, and now it's time to place this umbrella over the glass. We need to also rotate it. So this is the model of a martini glass. In this clip we will create the Apple logo in 3D. So let's start. I'll create a new file, then I'll activate the front viewport, then I'll go to options, configure, and here in the back tab click on this browse button and choose Apple logo file here. Okay, you can also drag and drop from the Explorer. Now the offset X, change it to 8, offset Y to 398, and change transparency to 90. Okay, now invoke the pen tool and create the shape. Okay, now let's adjust this shape. Like this. Okay, now we need to create other side of the logo. For that we'll use the mirror function. So press Ctrl A to select all points, then go to mesh, transform tool and mirror. You can also press MH. Now click and drag here in the viewport and snap this line to the start and end points of the spline like this. So now we have the other side of the logo. Now select the top 2 points here, let's zoom in on them and zoom in really close and select these two right click and choose soft interpolation, and then right click and choose weld or press MQ and weld these points. Okay, now we need to adjust the shape using the pen tool. Again, right click, not on the points but on the empty space here, and then choose soft interpolation and adjust the points. Okay, now select spline here in Object Manager and click on Close Spline. Now zoom in on here on bottom points, and if you see this is strange loop here, select these 2 points and activate the pen tool, right click on them and choose delete. Okay, so now we have one closed shape here. Next we'll create this cut in the shape. For that, first we'll create a circle spline, and then we'll align it with the cut here. Next we need to convert this spline to an editable object. So for that press C or click on this icon. Now select circle and then select spline. Make sure the selection order is correct. First select circle, then select spline, then go to mesh, spline, and spline subtract. Okay, now to create the sleeve, again we need 2 circles. So I'll create first circle here and align it like so. Create a copy using control dragging and create another circle. Now select both circles and press C to make them editable. Now make sure these circles are selected, and then we need to choose spline and from the tools from the mesh spline and option here. Okay, so now we have created the leaf as well. Now select both splines and then choose mesh, conversion, connect objects plus delete. So what this command allows us is to connect all the selected object into the one object, like we have here now a single spline. Let's rename it as logo. Now next thing we need to do is apply the extrude generator. So for that, select the spline and then choose extrude with Alt held down. Now in the object tab, set movement to 30 centimeters. We have the 3D shape here now. In caps, select fillet cap for start and end, and set step and radius to 3 and 1.5 for start rounding, and same for the end rounding. Okay. So this is our final output. In this clip we are going to create a whiskey bottle using the loft generator. So let's go ahead and create a new scene. Activate the front viewport, go to options, configure, and then click on the browse button and choose whiskey JPEG. In the back tab here in attribute manager, set offset X to 0, offset Y to 381, and transparency to 90. Okay, now we need to create a rectangle spline. set width and height to 232 each. Select the rounding checkbox and set radius to 8.248 and set plane to xg. Okay, now we need to create a copy of this rectangle. Rectangle 1, and it will be and the size will be 232 by 232. Now create one more copy here, and its size will be 225 by 225. Now create one more copy, rectangle 3, and its size will be 225 by 225. One more copy here, and it will be 232 by 232. Again 232 by 232, and here we'll have 225 by 225. Okay, so we'll place them in here in order, because when we'll apply loft generator to these splines, this order will be important there. So let's go ahead and add a loft generator object, and drag all rectangle splines inside that object. Okay, so we have this shape here. Let's turn off the loft object and now create a circle. And for circle, its radius will be 54 and plane will be xg, and then place it here. Create a copy and adjust its radius. So keep making circles to follow the shape of the model. Alright, so we have total 8 copies. Now let's move them in order: 4, 5, 6, 7. Now select all splines and move them inside the loft generator. Okay, and enable loft generator here. And this is the model we have created using rectangle splines. Now you can always go back and adjust the shape if you want to create sharp corners here. Okay, so this is our final product.